Hello guys, in today's video we're talking about indices. Now what is indices? Indices is the plural of the word index. Index is the number of times a number is multiplied, or it can be said to be the power at which a number is raised. So what do I mean by this? So we have a number or a variable raised to power 5. This 5 is the index, or we can call it the power. Why this a is the base. So what I mean by a raised to power 5 is the same as a times a times a times a times a. So going back to the first definition, I said that is the number of times a number or a variable is multiplied. So this variable is multiplied 5 times. That is to tell us that the index of the variable is 5. So we have a raised to power 5. So if we also have 2 raised to power 10, for example, this means 2 times 2 times 2 times 2 up to 10 times 2 times 2 times 2 times 2 times 2. Let's count 1, 2, 3, 4, 4, 5, 6, 7, 8, 9, 10. So this is what it means. Is the number of times a number or a variable is multiplied, or is the power at which a number is raised. So we'll now go to the laws of indices. So here are the laws of indices. We have product law, we have quotient law, we have power of a power law, we have power of a product law, we have power of a quotient law, we have zero index law, negative index law, fractional index law, and identity law. So I'll be explaining all these laws one after the other. So starting with product law. Product law, when we have a base with an index, say m, which is multiplying the same base. Note that this law applies when we have the same bases. So the same base with a different index or the same index n, we'll be having a raised to power m plus n. So this is what this law is saying, that when two same bases are multiplying, which each of them have their own index, we are going to be adding their index. This is what we have here. So let me say we have a raised to power 5 times a raised to power 2. A raised to power 5 is the same as a times a times a times a times a. So let me just explain why when we have a and when we have a raised to power m times a raised to power m, we are going to add their index. So this is a times a times a times a into 5 times. Now times a times a. So if we open this bracket now, we'll be left with a times a times a times a times a times a times a. 1, 2, 3, 4, 5, 6, 7, which is equal to a raised to power 7. So now using the product law, we have a raised to power 5 times a raised to power 2. So we have a raised to power 5 plus 2. So giving us a raised to power 7. So we have proved the law that when we have the same basis with multiplying each other with their index, what we are going to have is the addition of the two index. So that's product law. Here's another example. What if we have a raised to power 2 times 2 raised to power 5 times b raised to power 2 times a raised to power 5 times c raised to power 10. Let's say we have this. What are we going to do? Remember, product law applies when we have the same basis. So we'll pick the same basis and add their index. So we have a raised to power 2 and we have a raised to power 5. So a raised to power 2 plus 5 times b raised to power 2. We don't have another base again. So we have only b raised to power 2 times c raised to power 10 times 2 raised to power 5. So we'll be left with a raised to power 7 times b raised to power 2 times c raised to power 10 times 2 raised to power 5. So these two will now come forward. So we have 2 raised to power 5 times a raised to power 7, b raised to power 2, c raised to power 10. So this is our answer. So our next law, which is quotient law, is just the opposite of product law. when we have the same bases that are dividing each other, which have their index, so we say am over an, or we can put it as am divided by an. For us to solve this, we are going to be subtracting their index. So we'll have a, this which is equal to am minus n. So that is quotient law. So let me prove quotient law for you. Okay, let's say we have a raised to power 5 over a raised to power 2. Now a raised to power 5 is the same as a times a times a times a times a over a raised to power 2 is the same as a times a. So this is going to cancel this, this is going to cancel this. So we're having a times a times a, which is the same as a raised to power 3. So now using this law, we say when we have the same bases that are dividing each other with having their own index, we are going to subtract their index. So we have a raised to power 5 minus 2, which is a raised to power 3. So we have just proved the law here. So the next law we have is power of a power law. So power of a power law, when we have a base which has an index, say m, which is also raised to another power, say n, our value is going to be the multiplication of the two index. So we have a raised to power mn. So this is what power law is. So let me explain what I mean by this. So if we say, let's say we have a raised to power 5 all square. So we having a raised to power 5 times 2, which is a raised to power 10. Now this might look similar to Product's law, but they are different. In Product's law, we are multiplying the same bases that have their index. Now, when we are multiplying the same bases that have their index, we are going to add their index. But in this case, this base with an index has another power. So we are going to be multiplying their index. So this a raised to power 5 all squared is still the same as using product law. We say that when we have a raised to power 2, for example, we'll be having a times a. So now let's take this as a single term. We now have a raised to power 5 square is the same as a raised to power 5 times a raised to power 5. That's a raised to power 5 square. So to be double. So using product law here now, we have a raised to power 5 times a raised to power 5, which is a raised to power 5 plus 5. That is giving us a raised to power 10. So you have just proved power of a power law. So the next one is power of a product's law. Now power of a product's law, when we have different bases, say two variables or numbers, which is raised to a power, what we are going to be having is a raised to power n, b raised to power n. So this is what power of a product law is. So let's say we have a raised to a, b raised to power 5. We'll be having a raised to power 5, b raised to power 5. So that's what it's saying. Okay, let's say we have 2 times 5 all square. Using power of a product law, we'll have 2 square times 5 square. So the next one we have is power of a quotient law. When we have two numbers or variables that are dividing each other, let's say a over b, which is raised to a given power, say n, be having a raised to power n over b raised to power n. So that is what power of a quotient law is saying. So let's say we have a over b raised to power 5, be having a raised to power 5 over b raised to power 5. Okay, let's now say we have 2 over 5 all square. We having 2 raised to power 2 over 5 raised to power 2. Zero index law states that any number or variable raised to power 0 is 1, except that number is not 0. So what I mean by this is that, let's say we have 2 raised to power 0, we have 1, a raised to power 0, we have 1, b raised to power 0, we have 1, c raised to power 0, we have 1. So any number of variable raised to power 0 is 1, except from 0. So if we have 0 raised to power 0, what we have is undefined. So the seventh law we have is negative index law. Now, negative in when we have a variable, when we have a number or a variable that is a base with a negative index, say minus n, our value is going to be the reciprocal of the base with a positive power. So let's say we have a raised to power minus 5. Our value is going to be 1 over a raised to power 5. So it's just as if this 1, this minus has changed to the reciprocal, that's 1 over the base with the power. So that's what negative index law is. So let's say we have 2 raised to power minus 2. We're having 1 over 2 raised to power 2, which is 1 over 4. 2 raised to power 2 is 4. So that's for negative index law. So for fractional index law, when we have a base which has a fractional index, say m over n, our value is going to be the n-tooth of a raised to power m. So what we are basically saying here is that the numerator, which is m, has become the power of a, while the denominator, which is n, has become the n-tooth of a. So this is same as, we can put this as n-tooth of a all raised to power m. It's still the same thing as this. You can either use this or this, depending on the one that is most appropriate in the equation. So let's say we have 5 raised to power 2 over 3. This is the same as the numerator is going to be the square, while the denominator is going to be the roots. So let's say we are going to be having 5 square cube roots of 5 square. This is what we are going to be having. So okay, let's say we now have a raised to power 3 over 2, or let's put 5 over 2. So we say the numerator is going to be the power, while the denominator is going to be the roots. So we'll be having a raised to power 5 square root of it. The last law, which is identity law, states that any number of variable raised to power 1 is going to give that number of variable. So let's say we have a raised to power 1 is going to give us a, b raised to power 1 is going to give us b, 2 raised to power 1 is going to give us 2, 0 raised to power 1 is going to give us 0. So any number of variable raised to power 1 is going to give us that number of that variable.